Working with the quadratic in vertex form. Now be sure to watch the posted video that runs through 4 examples of how to sketch a quadratic in vertex form before we continue here. So just remind ourselves, here's a vertex form, here is our vertical translation, here's our horizontal translation, and here this is either our reflection or vertical stretch and compression. So here's one kind of question we could see. Given a graph, write the model. So here is the general case. Here's our graph. I know right off the bat, because the vertex is 2 and -9, I could put the vertex in right away. It's pretty easy, h and k. So there's my 2, there's my -9. Only the question is, I want to figure out what a is. And to do that, I'm just going to plug in one of the points that's already on the graph. So there's a point here at 5, 0. So I'm going to use 5, 0 and just plug it in. So where x is 5 and y is 0. We've seen this technique before. X is 5, y is 0. Now I'm left with one equation and one variable, so I can solve. 5 take away 2 is 3. 3 squared is 9. Add 9 to both sides, and then divide by 9. A is 1. And that allows me to write my equation given the graph. Another kind of question we could see is, given a specific event, write the model. And this is actually a little more of an interesting question, and these are the kinds of problems that we're going to come across with quadratics. So here's a situation here. Consider throwing a ball in the air. And the question would be, write a quadratic model that describes the path of this ball. That's obviously a parabola, but we're given some constraints. We're given some information to tell us about the path of the ball. So in this case, we'll just say we release the ball 2 meters off the ground. We'll give ourselves a maximum height of 20 meters, and we'll say that it occurs about 10 meters from the thrower. I'm going to call that a coordinate over 10 up 20, so that coordinate will be 10, 20. That allows me to start off my model. There's my h and my k, my 10 and my 20. If I throw my y-axis on here, the initial height will be 0, 2. So again, I can plug in that coordinate 0, 2 in for x and y, and now I'm back with one equation and one variable a that I can solve for. 0 take away 10 is -10. -10 squared is 100. There's my 100a. Take away 20 from both sides, and then divide by 100. That allows me to get my a. Then I can write my equation right there. All right, take a look at page 185.